So good day everyone. Today I will be explaining sample problems about keys and coupling. Um, First problem: parallel sunk key for high power. A 55 millimeter diameter shaft transmits 40 kilowatts at 350 RPM. Using standard proportion for a square sunk key, W is equal to T is equal to 18 millimeter. Determine the required length of the key if the allowable shear stress is 40 MPa. Check the induced crushing stress and evaluate it exceeds the limit of 80 MPa. So for the given na atay D is equal to 55 millimeter, uh, P is equal to 40 kilowatts, N 350 RPM, and width or and thickness is equal to 18 millimeter. Shear stress 40 MPa. So i-convert natin na siya sa meters. So naatay 0.055 40,000 0.018 40 times 10 to the 6th Pascal. So for the solution, kung ano to ang torque, natin formula nga P times 60 over 2 pi n. Diba, substitute na to ng mga given. Natin 40,000 times 60 over 2 pi 350, which will be equivalent to 1,091.348 Newton meter. So since natin torque, we'll use this formula. T is equal to shear stress times width times length times diameter over 2. So natin ang substitute at mga given. So 1,091.348 is equal to 40 times 10 to the 6 times 0.018 times L times 0.055 over 2. Shift solved, now the length which is equivalent to 0.055 119 meters or 55.12 millimeters. To check and then next solve for the crushing stress. So crushing stress is equal to 40 over thickness times length times diameter. Substitute the given 4 times 1,081.348 over 0.018 times 0.05512 times 0.055. So crushing stress is equal to 79.998 times 10 to the 6th Pascal or 79.99 MPa. So, moto final answer. And it does not exceed the limit of 80 MPa. Next, uh, clamp coupling frictional torque. A split muff coupling uses 4 bolts to connect two 50 millimeter diameter shafts. The bolts are tightened to a tensile stress of 70 MPa. Given a coefficient of friction of 0.3 between the muff and shaft, calculate the root diameter of the bolts required to transmit a torque of 600 Newton meter through the friction alone. So for the given, the diameter which is 50 millimeters, tensile stress which is 70 MPa, given bolts which is 4, coefficient of friction 0.3, then torque which is 600 Newton meter. For the solution, we will use this formula from torque. Torque is equal to coefficient of friction times number of bolts times tensile stress times area times diameter over 2. For the formula sa diameter, it is pi d squared over 4. So substitute the given at 0.3 times 4 times 70 times 6 times 10 to the 6 times pi dB squared over 4 times 0.025. Since na natin given na torque, solve natin na siya 0.3 times 4 times 70 times 6. Ay, sorry, 7 times 10 to the 6, then 0.025 na natin 210,000. After that, makakuha din ta og ay divide natin siya sa 4 o tag 525,000 pi d squared. So divide nato siya by 525,000 pi para makancel na siya both sides. So 600 over 525,000 pi is equivalent to 3.638 times 10 to the negative 4. Since naaman ta ay dB or root diameter squared, we will put square root ano na siya, square root ano na siya. So square root of 3.638 times 10 to the negative 4. Root diameter is equal to 0.0191 meters or 19.07 millimeters. Or ito, simple. Next, pin stress analysis, bending and shear. In the flexible coupling from problem 9, the 20 millimeter diameter pins are subjected to a bearing load of 1024 Newton. Calculate the maximum principal stress induced in the pin. Assuming the load acts at a distance that produces a bending moment of 21,504 Newton millimeter, evaluate if the result is within the safe range of 28 to 42 MPa. So for the given sa problem na atay diameter which is 20 millimeters, load which is 1024 newtons, and then bending moment which is 21,504 Newton millimeter. Wala na siya convert kay since wala naman na siya para dead sa na. So for the solution, use taning bending stress. 32 times bending moment over pi d cube. Substitute, which is equal to 32 times 21,504 over pi times 20 cube na atay answer na 27.38 megapascal. Then for the shear stress, we will use this formula 4 times weight load over pi d squared. Substitute 4 times 1024 over pi times 20 squared na tayo shear stress which is 3.26 megapascal. So para ano natin na siya, ipang-plus na natin na siya stress na gina-produce. So ay principal stress dahil maximum principal stress, i-add natin na siya 27.38 plus 3.26 is equal to 30.64 megapascal. So in conclusion, it is within the safe range of 28 to 42 megapascal since the maximum principal stress is equal to 30.64 MPa. That is all. Thank you.